Welcome back to my channel. In today's video, we'll be exploring how to analyze our data using Microsoft Excel. And as a food microbiologist in training and in practice, I'll be using microbiological data. And so this is specially dedicated to students in KNUST who have had the privilege of working on any microbiology related projects and they have to analyze their data. Many a times I realize that students walk up to you and then everyone wants to use one particular statistical package or application, but I would say that we need to master the statistical tools that are relevant to the kind of data we have and not really a particular application. I know Microsoft Excel is very common and almost every student has the Microsoft Office package on their devices. So I believe that MS Excel is something everyone has access to. And so that is why this is going to begin my series of video on data analysis when it comes to microbiological analysis. So let's start with descriptive statistics and then analysis of variance in Microsoft Excel. So descriptive statistics, it just gives you a summary of your data, or it describe, as the name implies, it's just going to describe the main features of your data set. So right from our basic education, we've learned some things about central measures of tendency, mean, median, mode, and things like that. So with the descriptive statistics, you're going to have all those information provided in your outputs in whatever application you're using. So it's going to give you the mean of your data sets. It's going to give you a median or some sort of central tendency or average. And then it's going to give you the mode or the most frequently occurring microbial count. It's going to give you the standard deviation of your um, or a measure of your variation or dispersion of your counts around the mean or from the mean. That's your standard deviation. And it's going to also give you the range. The range is the difference between the highest count you've recorded amongst your samples and then the lowest counts. That's going to give you the range. And then also the variance, which is the squared of the standard deviation. So it's based on this variance that we can go on further to analyze for the variance. That's the ANOVA, the popular ANOVA many of us have heard of, analysis of variance. So before you can analyze variance, you need to have some sort of average or some sort of mean. So it means that your data set cannot just be one. You should have at least replicates, two data sets for one particular sample or three data sets for one particular sample or more. And based on that, you'll be able to find an average or a mean and find variance. And out of that, you can compare the means, either using ANOVA or other things. But I know that ANOVA is a common one, so in this video, we'll be addressing the descriptive statistics and then ANOVA. So in microbiology, it's also used for just like in any other field. And once you collect data, you want to know how the data looks like, and that's your descriptive. You are describing the data statistically, and then the ANOVA is going to just compare the means, as I've mentioned, but it's used for comparison of means when you have three or more groups. So that is to say, if you have three or more samples, if you've analyzed, for example, in this particular tutorial, we're going to use data from analysis we did on Wasa Wasa. And to all the international viewers watching this, Wasa Wasa is a local delicacy normally found in the northern part of Ghana, made from yam. Um, I've not tasted before, but I hope that one day one of my subscribers in the north will give me an invite to the north. So that's with Wasa Wasa. So we're going to analyze the the results we have from analysis from wasa sample was just picked up from the local market and then analyzed for the microbial uh, microbes presence. That's the total count and other things. But for the purpose of this video, we are just looking at data. We are just looking at numbers and how we can analyze it. So we can use ANOVA when we are comparing microbial counts across different sample variants. So if you have different batches of a product, you can use ANOVA to determine if there is the difference between the batch 1, batch 2, batch 3 based on statistics. We can look at data ourselves and tell that, oh, this looks higher than that, but in statistical terms, is there any difference? That is what ANOVA is going to help us identify based on your confidence level and things like that. So you're going to get a p-value or a significant value from that analysis, and if you are analyzing your data at 95% confidence, that's what normally we use in our educational setting here, then your p-value, once it's less than 0.05, it indicates that indeed there is a difference between your batches or between your different samples. However, when your p-value or your significant value in some application, you see it as SIG, is greater than 0.05, then it means that there is no significant differences between the batches or between the sample variants that you have analyzed when you are looking at your data sets statistically and not just with the numbers you are seeing. So let's look at the data sets that I mentioned earlier on the wasa and then how we can find the description to that data and then also analyze the variance in such a data set. Yeah. So now before we use Excel for data analysis, we need to first of all activate that function in our Excel, in our basic Excel uh, window. So I'll be loading the Excel file very soon. Here we are in the Excel file. We have microbiological data for wasa, coliforms, E. coli, aerobic plate count, and salmonella in such a sample. So to start off, we need to first of all activate data analysis function in our Excel window. So let's do that. We'll go to File, and then we'll go to our options. So more options, and then at the add-ins section, I'm using Microsoft 2016. You can add on the analysis tool pack from here. So I'm going to select analysis tool pack. Okay. And then now it has been added here. Once I go to my menu bar and I go to the data, I can find data analysis ribbon here to work with it. All right. So before I even proceed to the analysis, I would first want to rearrange my data such that I have just my sample IDs and my results, because what I have here currently was analyzed from a particular template which I've shared in my previous video on how to calculate for or enumerate microorganisms. So I'm going to copy the data here into a new Excel sheet. So I'll name this as my final data, sort of, and I'm just going to analyze the aerobic plate count. So I'll pick my sample IDs here and then my results. That's the log CFU I mentioned in the earlier video, which will be attached to the description below. That always make sure you use the log CFU in your analysis and not the counts in CFU per gram. So I'm going to put that data in the final data sheet. Now, what you need to know is that if you used any sort of formulas in this sheet, in this current sheet, then you cannot copy the values you have there. You cannot copy the values you have here directly into the final data. You can copy, all right, I'm holding down the Control C on my keyboard. But when I come here, I need to paste it as values. Paste it as values. Because if you paste directly here, it means you are pasting the formulas. And we don't have those cells. Cell A2 doesn't have any number here. So you would get these errors. So I need to paste them as values so that the values I have here, the numbers will be pasted in this section. Now I want my data to look a bit more nicer, so I'll leave them all in two decimal places. So now I have my aerobic plate counts. Let me leave set the title here. And then the sample ID and then my count. So now I am set for the data analysis. Now in Excel, before we do data analysis, we need to ensure that our numeric values are either in the column format or in the row format. What I mean by that is if we want it to be in a format as this looks like, then our first sample, which is a WA, should be here with the counts here. Then the replicates count should follow so that there is nothing here. And the next one too, the replicates will follow here. And with that as well. So we can have our data arranged this way, or another format is to have our data arranged um, with the WAM, WLM, WCM, which are the sample IDs on the first row, and then numeric values in the columns. So this is the column format, this is the row format. As we all know, Excel works with columns and rows. So you need to master which one is column, which one is row to be able to work well in Excel. So if we are using this format to present our data, we have to first highlight the data set. And on our menu bar, we go to data and select data analysis. This should be after we have already activated it. So you can see a lot of tools here, ANOVA, correlation, a lot of them. So we need the descriptives for now. So go to OK. And as I mentioned, this has been arranged in the row. The inputs, that's the numeric values, are in the row format. And so I'm going to make sure that that has been selected. And once you select the rows, it means that your labels would have to be in the column. So the labels are the titles. These are my labels. The labels are in the first column. So let me select the labels so that it will recognize the labels as well. Okay, and my labels are in the first column. I want the outputs to be in the new worksheet. rather than opening a new Excel. So the new worksheet, I'm going to label that as descriptives. Descriptives. And I'll hit my OK. And voila, here we are. So this is the descriptives I have. For the sample WAM, this is the mean value, that's the average, that's the standard error, that's the median. And the same for WLM. The mode, it has no mode because there was just two data sets and each of them had just one appearance or one count. Standard deviation is here. Sample variance is given here. Kurtosis, it's invalid. Skewness is invalid. The range has been given. That's the difference between the highest and the lowest. Maximum is 7.2. Minimum, and the maximum is 7.21. So when you subtract, you get the range. And our sum and the counts. That's the number of data sets we have. They are just two. And the others are also here. So we can report our results as the mean plus or minus our standard deviation. This gives us an idea of how the the data we've gathered looks like. And from here we have variances, so we can analyze these variants as our ANOVA in the ANOVA table. So let's look at the ANOVA now. With the same data sets selected, you are going to find ANOVA. It's going to be a single factor ANOVA. Then our data sets is going to be this way. Okay, since we use the columns in the first one, let's use the rows this time around. So I'm going to select the same data, but the one that has been entered at the side. So I'll choose group by rows. Sorry, group by columns. And so my labels are in the first row. The first one was grouped by rows and the label was in the first column. Okay. So I'm going to label the worksheet as ANOVA. And here we are. So we have two counts, that's two replications, and the sum is 14.41, the average, and the variance is given here. You may want to make this possible. And then the ANOVA, the analysis of variance table, is what has been given here. Between the groups and within the groups, and we have our F value, we have our P value, and normally at um, for the analysis of variance, trying to find the difference between your product categories, you may be considering the p-value to tell you whether it's significantly different or not. So within these three categories of wasa wasa, since our p-value is less than 0.05, remember we set it to 0.05. So since it's less than 0.05, then we can say that between these three groups of samples, there is a significant difference between WAM, WLM, and WCM. So that is with the analysis of variance also in Excel. So now let me attempt to explain the ANOVA table we have, so that you understand all the parameters that have been listed there in your ANOVA table. So the First of all, let me enlarge this. This is our ANOVA table. The source of variation is telling us where the variation is coming from. And we have between groups and within the groups. So between the groups simply means that we are measuring the variation as a result of the interaction between the groups of samples. These groups of samples, these three groups of samples. And it shows how much the group means or the group's averages deviate from the overall mean of the three. And then within the groups, also measures the variation within each group, because within the WAM we had two sets of data. So it shows how much the individual observations we've had within each of the groups deviate from the respective groups. So how the observations we've had in WAM differs from that which is in WLM, and that which is in WLM, how it differs from the WCM. So that is with the within the groups, the source of variation within the groups. And the total is the total variation in the data itself, the sum of the variation between the groups and then also within the groups. The SS here simply means sum squared, sum of squares. So within the groups, this is the sum of squares of the variation, and then within is also that the total is the addition of these two. Now let's look at the DF. The DF is the degrees of freedom. So with the between groups, the degree of freedom is the number of groups we have, these three groups, minus one. Always degree of freedom is n minus one. So that gives us the two. And then also when we look at the within the groups, that is giving us an idea of the total number of observations. So in our case, there are three groups, two observations for each of them, making six. So the total number of observations minus the number of groups that we have. So if we have three samples with two observations each, it's going to give us six total number of observations. And within this six, we subtract the three groups from it, we are going to have three, and that gives us the degree of freedom within the groups. The total of it is five. And the MS is the mean squared. So between the groups, the average variation between the groups that has been calculated. That is the mean. The mean is going to be the SS, the sum of squares, divided by the degree of freedom between the groups. So the sum of squares divided by this degree of freedom gives us that. And then the same for this. We have that also. Now the F value is the ratio of the mean square of between the groups divided by the mean square of within. So the ratio of these two, that gives us the F value. So that is to help us test our null hypothesis that the group means are equal. So a higher F value indicates that there's a greater probability that at least one group mean is different from the others. Then with the P value is um, what we normally use in order to find the significance, as I've talked about earlier. So I will not go into that again. And the F crits is the critical value. That's the value from the F distribution table based on the degree of freedoms. So that's also with that. So this gives us our ANOVA table, and then our descriptives also is equally here. I hope that you found this video helpful. Stay tuned for more videos. I'm going to do the same analysis using different statistical packages, SPSS, and hopefully Stats Graphic or any other software you would want me to talk about. So you can leave a comment in the description section. You can leave a comment in the comment section. Tell me what you want to know regarding data analysis in Excel so that I can consider it with my team in developing my next set of videos. Thank you for staying tuned for this tutorial. Consider subscribing to the channel if you have not. You will find valuable information here. See you in my next video. Bye for now.